Saxon Algebra 2, Lesson 3. Students, I have good news. Today, we're just going to get into some plain and simple algebra. Enough with the drama and the geometry. Let's just do some algebra. Without further ado, let's dive right in. Evaluate. I'm going to write the words out just so you can remember what kind of problem this is. X squared y minus y if x equals minus 2 and y equals minus 4. Okay. Hi, Grace. She just woke up from her nap. What we have here is called an expression. There's no equal sign. That's how we know it's an expression and not an equation. And we see that something like this, we could plug in anything for x and y and get different numbers, right? So we can't do anything with this unless John gives us some values to input for the variables, right? Okay, so that's what we're going to do. We're just going to plug in minus 2 when we see an x, and we're going to plug in a minus 4 when we see a y, and it's all going to be good. Now, huge, it's not even a tip, you guys. It is a mandatory step. You have to use buckets in these problems or you will make a giant mess, all right? So what I'm gonna do is rewrite this, putting buckets in for every letter, being very precise to copy the problem exactly the same, only buckets instead of letters. Now, when I put my minus signs in, I have order instead of chaos, because look, there's a minus sign in the equation, expression, there's minuses in the values. It would be a hot mess. I could screw this up, the squaring, I could screw that up really easily. Please use buckets. Please, 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 I beg of you. Okay, now we just simplify, and again, we're gonna keep our order of operations in mind when we do that. So let's just remind it of how that works. It's exponents and roots. We do those first. Then we do anything in parentheses or symbols of inclusion, if we want to be fancy. Then we do our multiplying and our dividing, and then last we do our adding and subtracting. This is the order of operations. So we're going to want to do that. All right, so the first thing we'll do is this power, right? We'll do that. This, because of the parentheses, we can see the minus sign goes along for the ride. With the squaring, we can't cover it up. So this becomes positive 4, and then I'm just going to copy this all over again. Now we see this is multiplication, so we can do that, minus 16. And then we'll get ready to add, but we can simplify that. So our final answer is minus 12. Cool, right? That is what we're going to do for the first half of this lesson. We have a couple more examples, just one more, and then we'll switch to the second topic. Example 3.2. And there are only 2 topics, so how about that? Evaluate. I'm not going to write the word now, you understand. This one's longer. You can see there's some subtracting and there's some multiplying going on. We don't have any powers or roots, but we're going to work with the symbols of inclusion, aren't we? Okay, A equals minus 2, B equals 4. Again, this will only work if we use buckets. Otherwise, we're going to have drama. We've got minus signs in our expression. We've got minus signs in our values, one of them. So we don't want to fool around. Now, because I'm creating buckets, but there are already some in there, I exaggerate those so that I can tell the difference between the buckets I'm creating and the buckets that John put in there, because we need to know the difference. All right, A is minus 2. So I put that into all the minus 2 slots. B is 4 and 4. Okay, now I'm ready for order of operations. We already covered it. Nothing there, so we go to this. So I want to work on what's in here. What is even happening in here? Okay, it's this number and then adding here. So there's no multiplying in this. I just have to get that straight in my head. So this is going to be minus 4 plus 2. So now I'll rewrite this. Minus 4 plus 2 is minus 2, right? So now I can see I multiply here and I multiply here. I guess I should write that number in. Right, I've got 2 chunks of multiplying and that's what comes next. So this becomes positive 4 minus, and then this is minus 8. And then for my final step, I'll add, and my answer is positive 12 this time. Okay? This process isn't difficult, but man, you just have to keep your wits about you, right? And go not necessarily slow, but careful and meticulous, not to rush or screw things up, or write messy so that you can't tell what you're doing. That's another fatal flaw. All right, now we're switching categories. Oh my gosh, this is such a nice short lesson. I just love it. Our second topic is adding like terms. And I hope you're smiling right now because you're like, dude, adding like terms is easy. And you're right, it is. Example 3.3. Simplify by adding like terms are our instructions. Let me copy it down. Okay. That's a Y and an X. It looks a little crazy. All right, so let me just review a few basic things to help get your head in the right place. Terms are clumps of numbers. They can be multiplied or divided within, but when we move, like here with a subtraction sign or here with an addition sign, these are connecting different terms. A term is a clump, okay? There's a scientific definition for you, a mathematically precise word. It's a clump. So this is a clump, that's a clump, that's a clump, that's a clump, that's a clump. Within each clump, we may have numeric values and then we may have variables, all right? Usually we call the numbers the coefficients, but they're really all coefficients because all 3 of these things are being multiplied together. This is called a numeric coefficient because it's a number. But these dudes are all being multiplied. We all know that in multiplication, order doesn't matter, right? So that means that if I'm writing the letters YX, it's the same as XY. And that's why whenever I copy a problem out of the book, I always put the letters in alphabetical order, even if John's got them scrambled, because I know that's going to help me make sense of it later. So if I was doing this as homework, I wouldn't have even copied it crazy like that. I would have written 3xy minus 2x plus 4 minus 6xy plus 3x. That's what I would have written. Don't even waste your time on copying it the wrong way. Now I can easily see my like terms. Like terms are bundles of matching letters. The numbers can be different, but the letters have to be the same. And the sign goes with it. So that minus sign I need to pay attention to. Now what I can do is combine these two. 3 minus 6 gives me minus 3xy, right? You just add / subtract the numbers in front. Once you determine that the letters match, you can ignore them and just pay attention to the numeric coefficients. All right, now I can do the same with my x terms. There's 2 of them. They both have a plain x. Minus 2 plus 3, that's going to be a plus 1. I know that I don't have to write a 1, so I can just write plus x. All right? And then there's only one plain number term, so I will copy that as is. What am I doing here with these markings? What I'm doing is I am making notes to myself to help me see which pieces I want to combine. Not only does that sort of train my eye where to look as I'm combining each type of term, but it also helps me make sure that I've included all of them in my final answer. Because sometimes if you get really long ones, you'll like drop a piece and lose track of it. So that helps me glance through at the end and go, oh yeah, I've got everybody. That's the right answer. Yay. All right, this is our last example for this lesson. I know, you are crying. You are saying, no, don't let it be over yet. I'm having so much fun. Don't worry, this one's nice and long. Because look. Look how long and disgusting that is. Again, if I was doing my homework, I would not copy it like this. I would look at this in the book and I would go, dude, these negative exponents have got to go. I'm going to fix them as I write down the problem, and I'm also going to make sure everything's alphabetical. It looks pretty good as it's written in the book, except for this. I don't like that. So I'm gonna rewrite this. And remember, our negative exponents flip down like a trapeze. So the A term is going to go down here, and I'm just going to have B up top, and then below I'll have A squared C. See how that's a new and improved version of that? This one looks good. I don't think I have to do anything to that one. This one's a hot mess. I can copy the plus. The A and the C have got to go. The B will stay upstairs. The A is squared. The C is a plain number. And then here, what I have to fix is just the order. The A has the square, and then the B. Right? Okay. I double check, I make sure it's right. Again, I wouldn't even bother copying it wrong. That's just annoying. As I was writing that through, though, I got really excited because what I noticed is that this B in the numerator and A squared C in the denominator is the same in these first three. Now, I notice this is close, but it's not quite right because the A squared is up top instead of down below. And sometimes that might be John's design. Excuse me. But other times, I'm not bored, trust me. The yawn is my brain being overwhelmed by the fun of this. This might be right, because John does sometimes throw us a wild card in here, but it might be that I copied it wrong. So I double check it in the book and I see, no, I copied it right. That does not match to the pattern of the others. So he's an oddball, we have to set him aside. In the meantime, I can just pay attention to 3 minus 4 plus 7. I have to pay attention to those two, don't I? 3 minus 4 is -1. -1 plus 7 is +6. So the coefficient simplifies to 6, and now I can just copy the letters. 6b, A squared C. This guy's an oddball. He does not match, so all I can do is just copy him as is and say, sucks to suck, little term. I'm sorry that you could not fit in with the others. And that is my final answer. Fun, right? I know, so exciting. All right, so now you are ready to do lesson 3, the practice. Please do all 3 of the practice problems, and then the odds of the problem set. Thank you, goodbye.